right, so now we're going to find the sum of a series. So remember how I said series is because we're adding each of the terms in a sequence together. So a lot of times what we want to do is we want to find out what all those numbers added together equal. So we're going to start by looking at summing terms 1 through 10 of the series beginning with 1 plus 2 plus 3 plus 4 plus, well, 5 plus 6 plus 7 plus 8 plus 9 plus 10. Those are the first 10 terms. So this is a series where a equals 1, the common difference is 1, and the number of terms is 10, okay? And we also know the last term happens to be 10, right? Well, you're probably thinking, well, I'm just going to plug those into my calculator or do it in my head. That's not too bad if I had to add 10 numbers that are consecutive. Well, the problem is that you're not always going to have a series with only 10 terms or numbers this small. You might have a series with, 10,000 numbers, and you certainly wouldn't want to be plugging 10,000 numbers into your calculator. So I'm going to show you why the formula I'm about to introduce to you works, okay, and how it was derived back in the day by some mathematicians. So I wrote every term in our series, so 1 through 10, okay? Now, if I'm going to add them together, I could also maybe add the first one and the last one. I could go backwards, right? So I'd only have to add a few of them. Okay, just follow with me for a second. Okay, so what you're going to notice is at this point, the middle point, I haven't used any of the numbers twice, right? Here, now I've repeated my numbers, so I don't really want to use the second half. So what I've done essentially is I've cut my values in half, okay? But here's what's cool about this. What's 1 plus 10? It's 11. What's 2 plus 9? Also 11. Are you noticing a pattern here? These are all going to add to 11, okay? So I end up with 5 groups of 11, which means that my sum is 55, right? But what's really happening here, okay? So one of the things that I definitely did is I had all 10 terms. So when I'm writing my formula, I'm going to say the sum of my 10 terms because here's 10, 1 through 5, 6 through 10, okay? I cut them in half. See how I wrote 1 this way and then I wrote it backwards and I summed them to 11? Well, I only used half of the row, okay? So I'm going to say half, okay? And then I said that I used all 10 terms, right? So I'm going to say times 10, okay? And then basically what's happening is I'm adding my first term and my last term, my second term and my second to the last term, my third term and my third to the last term, and so on, right? In math, we want to use the ones that are easiest to remember. We could use any of these, but we're just going to say my first term and my last term because that's the easiest to notate. So I say 1 plus 10. And look what happens. I end up with 55. So that's how the formula that I'm about to show you with variables gets derived, okay? So, I think that's useful to know, to keep in your mind so you know what's happening. Here it is with variables, okay? So this says the sum of n terms. So n is the number of terms equals half times the number of terms times the first term plus the last term, quantity first term plus last term. Okay? So this is essentially what we did on the page before. And we use the first term and the last term because it's a whole lot easier than saying the second term and the second to the last term, or the ninth term and the ninth to the last term. It's easier to know the first and the last. So you would get the same result regardless of what you use, because look what happens when you sum them, you get the same number all along. Okay? There's another formula you could use, and basically it's a combination of this formula and the last, finding the last term formula. So remember how we did this a bit ago, where we found the last term using this formula? What basically happens is we could combine this formula with this formula. So in case we didn't know the last term, we could use one that has the last term accounted for in here. So do you see how we have an L here? We could substitute whatever L equals in for that. So when we do that, we end up with S sub n equals half n times A plus D times quantity n minus 1. Well, this simplifies to half n times 2A plus D times quantity n minus 1. So if, for instance, we don't know the last term, we could use this summation formula instead. If we know the last term, we'd want to use this one. Or, if you don't want to have to kind of remember this, you could say, well, I know this equation, so I'm just going to find the last term and I'm going to plug it in here. That's all this green equation does. Okay? Alright, make sure that you have this equation written down in your notes and highlighted because you're going to be using it a lot. So let's go ahead and get to some examples. So the first example, it says find the sum of the first 25 terms in a series beginning with 1 plus 9 plus 17 plus 25 plus 33 plus da 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 all the way until we have 25 terms. So we're going to go ahead and start listing before, just like we did when we found the last term. So we're going to list our first term, which happens to have a value of 1. So A equals 1. Next, we need our common difference. So we're going from 1 to 9, which is 8 units, 9 to 17, which is 8, 17 to 25, which is 8, and so on. So our common difference is 8. Okay? Our number of terms is 25. That's given because it says the first 25 terms in a sequence. And we don't know the last term yet, but we could certainly find it. So I'm going to go ahead and I'm going to show you how to do it both ways. So I'm going to find the last term first. So if you remember, we already learned how to find the last term using this equation. So L is going to equal A plus 8 times quantity, 25 minus 1. So L equals 1 plus 8 times 24. Okay, and then if you just go ahead and put that into your calculator, you get a value of 193. Okay, so L equals 193. Okay, so now I'm going to go ahead and put it into my summation equation. So the sum of n terms, well, n is 25, equals half times the number of terms, which is 25 again. These two numbers always have to be the same, okay? Times quantity, term 1, A, plus L, okay, which is 193, okay? So if I go ahead and I just pop this into my calculator, I end up getting a sum for 25 terms of 2,425, okay? So that's how you would get the sum if you wanted to use, find the last term and then plug it into the summation equation. But if I didn't want to do that, and I wanted to say the sum of n terms equals this equation, which is what we talked about, okay, I could use this, and you'll see I don't have to have the last term here, but I do need to know the common difference. So remember we said A is 1, D is 8, and N is 25. Okay, so if I say the sum of 25 terms equals half times 25 times 2 times 1 plus 8 times 25 minus 1, if I go ahead and put this into my calculator, you're going to find out that I get the exact same thing that I got before. Okay, so because this is equal to the first term plus the last term. Okay, so I end up with 2,425 again. Okay, so that's how you do a problem finding the last term first and then plugging it in, or by using the formula in which the last term is not required. Alright, so here's another example. Sally is starting a running program. She plans to run every day for 2 weeks. On day 1, she runs 400 meters. On each subsequent day, she runs an additional 200 meters. how many total meters does she run in that 2-week period? So sometimes I hear people who run say things like, oh, I ran 55 miles this week. Well, they're essentially using a series. They're saying I ran this much on day 1, and they're adding it to day 2's distance and day 3's distance. So we can do this for Sally. So I think we're going to start by writing the sequence. So she started with 400. On the next day, she ran 200 more meters, which is 600. Then the next day she ran an additional 200 meters, which is 800. Then an additional 200, which is 1,000, and so on, okay? Well, if this is a series, we're going to put some plus signs in here because we want to add them, okay? So let's go ahead and make a list of what we know. We know A is equal to 400. We know that D is equal to 200. And we know that n is equal to, well, n is equal to how many days there are in 2 weeks, which is 14. Okay? So I'm going to go ahead and use our longer formula. You could find the last term, or you could use a longer formula. It's up to you. So again, here's the formula. All right, so we're going to say that S of 14 days, so the sum of 14 days of running, the distance here, is half times n is 14 times 2 times quantity 400, okay, plus 200, that's our D, right, this is D, times n, which is 14 minus 1, okay? So if I go ahead and I simplify this, I end up with half times 14 times 800 plus 200 times 13, okay? Or you could have just put this into your calculator straight away, but if you want to simplify, this is how you do it. So when I sum this together, I end up getting a distance of 23,800 meters, okay? So this is how fast this is not how fast, this is not speed, this is how many meters she ran in 14 days.